So, we have arrived to the last day of Dune. What a bittersweet statement. Today, like last week, is our combined and generalized day, where we are going to cluster all pairs containing USDC using some combination of the stability metrics that we've covered this week. Without further ado, I will hand it over to Andrew to do the exploration. Let's have some fun.
Okay, so let's get into the last walkthrough. This is going to be a fun one. We're going to put together the volatility and magnitude of USDC pairs. We're also going to take the concentration of all pairs and combine it in a single metric, which is just going to be the HHI, and I'll go over that later. And then we're also just going to take the percent reserves and reserves notional of all pairs, or all USDC pairs. Cool, so first thing we need to do is just to get all USDC pairs. So let's do, as a parameter, select all from, we need the factory. Pair created function where token 0 equals token address or token 1 equals token address. All right, and we're going to have this be USDC. Cool, let's put a bracket around this. And something else we want to check off the bat is just for activity, right? So let's do like a ignore inactive pairs equals keep, or now we're gonna say this is a list where ignore is the default. And then we're going to say, or the pair is in select contract address from, we need the swap event where the event block time is greater than now minus interval some months. Right, so in is actually a little slow here. So instead we're going to use exists, which is basically in just a little faster. And it's going to be where contract address is equal to, let's rename this to PC. Is equal to PC.pair. Don't worry too much if you don't understand exists. It's like doing a join without doing a join, is how you can think of it. And we only want pair from this. Cool, so we have our USDC pairs. Now let's bring in volatility. And I'm just gonna go to the query Jackie went through yesterday and essentially just copy paste all of it. Right. So this is going to be the easiest one for us to bring in because there's basically no work we have to do here besides saying where contract address is in, select pair from pair params. I'm going to do this again down here. Right. And the only other thing we want to add is we want to add like a minimum liquidity check. So I'm going to call this minimum liquidity met as select pair from, let's see, which one is it? Should be liquidity price notional. It should be, yeah, so it should be liquidity price notional where I think it's called time, yeah, where time is the max time from liquidity price notional, and we want where k liquidity is greater than or equal to 1,000. And this is just the minimum liquidity set in the contract to be tradable. We're gonna have a lot of pairs that have no liquidity, and we don't want to analyze those. It's not really, they're dead pairs. So in our analysis, they're not relevant, right? They're past low quality. I don't need this. And now I'm gonna do a join on, let's do this, where exists, hold on, where ignore inactive pairs is equal to keep, or exists select one from minimum liquidity met where pair equals d dot pair. So if it's keep here, then we don't do anything. If it's not keep, then we have to check that the pair meets the minimum liquidity. All right. So we have volatility done now. The next thing that we want to have is just percent of all liquidity. So this is percent liquidity pairs as, and this is going to be our day. So this is going to be our day 9 query. So if I just take all the work we did here, copy it into here, total token reserves. Cool, so this is still getting all reserves, which is exactly what we want, except I'm gonna start doing something here where we want to switch essentially token 0 and token in a way that token 0 is always USDC, right? This is just to make the data more consistent and easier for us to analyze later on at the end. You'll see, it'll make sense. So I'm still gonna have a select all from here. I still want to do the divisions, except now at this step up here, we don't need block time. We still need pair. And I'm gonna have a bunch of case ones now. I'm gonna say case 1 token 0 address equals token address. Then I still just want to keep token 0 address here, else token 1 address as token 0 address. All right, so you can hopefully see where this is going, and we're gonna have a bunch of case ones, but that is unavoidable for the flip we're trying to do. I do the same thing for token 0 address, right? We're gonna do the same thing for symbols. Flip these around for token 1. And we're going to do the same thing for reserves. Flip these around. And that's all we need from the reserves here. So now token 0 is always going to be USDC in our case. I still have pair address in here, so I want this to be where in select pair from pair params. All right, and same thing here. Oh, this was a union all, right? Because we wanted the columns, but we actually don't want this anymore. Now we want them all together. All right, and I'm actually going to move this up to back here. Do I want to do this? No, I'm going to keep it down here. This is token 0. This is reserve 0. This is all reserve 0. This is percent reserve 0. And then this is token 1. Reserves 1. All reserves 1. Percent of reserves 1. And then while we're here, we might as well just get the... Oh, hold on. I also need this left join still. So we're joining once on token 0 and once on token 1. I also want to get the number of pairs, right? So back when we were getting total reserves, where this was saying, all right, for token address, sum up the different reserves across all pairs. I can just add a count here and get num pairs. This might be useful for us, so let's just pull this data. And this is going to be ttr0.num pairs. And we're going to want this for token 1 as well. We may use it, we might not, but let's bring it in here. Cool, so that gives us the percent liquidity of pairs. Now, last thing we need is concentration pairs. So for this, we're going back to day 8, and I'm going to copy in everything from day 8, where we took basically the LP token balances for a given pair, and then divided everyone's balances by the total supply, right? So you can get what percent of liquidity they're holding. So all of the equal pair addresses, I'm going to change to select pair from pair params. All right, nothing else needs to change. And then, right, so I don't need the creation traces anymore. So I don't need this case when, but here's where we have the first problem of something we actually need to change, right? In our case, this would give us every holder for every pair, and that's not something we can actually compare with. So instead, we want to represent the liquidity concentration with one variable. In my mind, the first thing that came up was the HI index. I can't pronounce it, Herfindahl-Hirschman index. Essentially, it's a competitive measure of market share in economics, but you take everyone's market share and square it and then add it up, right? So the most concentrated market would give you 10,000, right? Because that means 100% of the market is owned by one participant. So 100 times 100 is 10,000. And they define competitive as usually 1,500 to 2,500. So we're going to take the same line of thinking here. If we see an HI of lower than 2,500 or so, then that pair's liquidity is not concentrated. If it's higher than 5 or 6K, then it's probably pretty highly concentrated, right? That means more than like 30% of supply is held by one address. So how exactly do we do this, right? There's two ways. First, though, I'm just going to take a count so we can get number holders of the LP token, right? Now, if we wanted to get HI, the easiest way is probably taking the sum of the power of percent liquidity held, which would be this here, and we want to take the power of it squared, right? And this would be HI. Easy method, right? But sometimes formulas are more complex than this. So I'm going to show you guys how to use reduce aggregate instead, right? So reduce ag allows you to do a lambda function, which a lambda function basically says, okay, I have some starting point, right? So some starting value, and then, or sorry, I have some column. So this is your column. And then you have a starting value, call it 0. And then for every row, like every consecutive row in the column, you can choose how to add them. So let's say S is the first row, X is the next row. I can then say, all right, the way that, so S starts at 0, right? And I'm going to do something with X on each column, right? So if I had a much more complex formula, then I could basically use this to do an operation like on the sum as well as on the new row, right? In this case, I'm just taking the power of the next row to 2 and adding that onto the sum. And then once I have this, I want to add together all rows, right? So row 0 plus row 1. And I'm just going to literally do row 0 plus row 1. And now that I have this, these two will basically be the same, right? Again, this is probably confusing for you if it's your first time seeing lambda functions, but this is the lambda function that's like transforming the row itself. So assuming if your row is an array, this would pass in the array and do all the operations on that array. And then this is doing the operations like across, like down the whole column, right? So now it's saying, all right, we've calculated like some formula for each row. Now we want to add together the rows. And in our case, we can just do this, right? In fact, I could leave this as X, right? So if S is 0 and adding X is just the value of the row, then S plus X, 0 plus X is just X, right? And then instead here, for every single row, I could take the square of the row, right? So that would say, okay, each time you add the next row, but I'm going to keep the power here for now. We're going to comment this out. This is an aggregation, so we have to do a group by. And we're actually done with getting all of our columns now. You'll notice I didn't run anything yet because this query takes a while to run. So we're going to put it together and just hope it works. Is my auto suggest off? No, it's on. Percent. There we go. Percent liquidity pairs is what we're going to start with. And this gave us all of the reserves, where reserve 0 is in USDC. Oh, I'm noticing I didn't put a month here. Let's put 10. So I actually want a minimum threshold for reserve 0. There's some tokens that have like maybe 1 USDC or something left. So let's just call this minimum token balance, like liquidity requirement. Oh, that could be confusing. Token reserve requirement. And let's say that you have to have 5,000 USDC to even show up in our results, right? So because we have pair, we can take a concat of, let's see, token 0 and token 1 as pair symbol. All right, so let's just start here. P dot, because that's a column on the P table. We're going to take all of the rows from P, and something we can actually do here is take slippage from 0 to 1 swap, right? So when you're swapping USDC to whatever your other token is, we can calculate the slippage for it, all right? So to do this, I'm going to take our slippage equation from here, right? So from 0 to 1 is this formula. So this was our amount out, right? But we want to divide amount out by amount supposed. Sorry, I said slippage earlier. Price impact. It's not slippage, Andrew. So we're going to divide this by the supposed amount. And then we're just going to subtract all of it by 1, because this gives me some percentage terms of how much my order is being fulfilled. And then, or not fulfilled, but this is how much the price is going to resolve for. So 1 minus it gives me like the change or decrease or price impact as price impact 0, 1. But we don't have a 0 amount simulated, right? So I'm going to make this a parameter, simulated amount. And for USDC, let's just make it, what is the slippage for swapping 2,000 USDC? And so this should give me price impact. Cool. So now that I have that, we can move on to getting the rest of our tables. So let's left join volatility V on P dot pair equals V dot pair. So this is volatility. And we're just going to take V dot standard deviation of K, V dot standard deviation of price, and magnitude, right? Now we also want concentration. So we're going to take the left join on concentration pairs, where we're joining on pair again. And we have, let's see, we should do C dot num holders and then C dot HHI, right? So we have all of our data points now. Let's order by P dot reserves descending, so we get the token pair with the highest reserves first. And now we're going to run the query save it as day 12 clustering USDC pairs by stability. Save it. Mismatched input group. All right, let's start debugging. So line 165. I'm missing a parentheses here. Let's try this again. 288, expecting order. Am I missing a parentheses? Oh, I don't have the column name in here. All right, so our column was this, but this gives me percentage terms, so I'm going to multiply by 100. And this should be fine now. All right, I have something messed up here. I can't really read this, so let me reformat. SX row 0. $291 is the issue. Oh, I put a plus here. This has to be a comma. Reserve 1 cannot be right, because we redefined it as reserves. And just to make it clearer to people reading, we're going to put the P in front so people know where our values came from, like which table to look at. Is always the input token address so that we can simulate correctly. And all right, we're gonna wait for this to run. Okay, so we have our results. Things are not quite in the order that I would like them to be. So we do actually need to type out the columns we want. Right, so we want pair for sure. We want percent all reserve 0. We want reserve 0. We want to have the number of pairs for reserve 0. So p.num pairs. Actually, where did I define number of pairs? Number of pairs. I didn't define this is num pair 0. This is num pairs 1. All right, so I want num pair 0. And then we want this. Let's see, p dot reserves all reserves 0. This is 1, this is 1, this is 1, this is 1. Summary, parametrics. All right, so we have all this. Let's run it at TTR 227. Num pair 0. We're just gonna rename things here. All right, our data has loaded and things are in the right order. Let's do a quick sanity check with a cleaner table. I'm gonna call the table summary. We want the pair symbol. We can keep the pair address to look clean. And let's change this to 0.0a. All reserves 0.0a, percent of reserves, we can pad with a few zeros. Number of pairs, reserves 1, all reserves 1. Pad a few zeros for percent again, num pairs. Price impact, this was in percent. Standard deviation of liquidity was in percent. Standard deviation of price was in percent. Magnitude was not in percent. Number of holders, not percent. HI is just that. All right, so now we have a summary table, and we can see reserves 41.7 million USDC. That checks out. 35.1k ETH. That checks out as well. Price impact of 0.3%. That is correct. Looks like our standard deviations here are off. Number of holders and HI also looked correct. So there's something wrong going on here with standard deviation. Let's check it out. Let's see. To make it easier to debug, let's change this where in to be where s.contract address equals the WETH pair. Now this is purely for QA. And let's do the same thing up here for reserves. Now, easiest way for me to QA this is to double check before we do this. So I want to double check here. Select all from liquidity price diff. Right, and let's just run up until here. All right, so we can see the percentages actually look fine here. Let me just double check the joins. So here we're joining on both time and pair. That's correct. We do a time series. And oh, looks like we're missing a join here. We also need to join on pair here. And that should be the last join. All right, so I believe that was our mistake. Let us filter some of this back. So we changed this and we changed this back. Let's run it. All right, it's run again. And this time, our standard deviations price changes, or standard deviation of liquidity and standard deviation of price and magnitude makes sense. So now this is correct. If you're wondering why it's slightly different from the query yesterday, it's because I'm only looking at 10 months today. I'm not looking at 20. All right, so now that we have a summary, let's look at charts. So first, let's put number of holders with HI. Basically, we're gonna try to look at liquidity concentration. All right, so if I take the logarithmic of both, I can see, all right, as you get more holders, the less concentrated liquidity is, which makes sense. But it's good to validate our assumptions. So number LP holders, and let's just 0A this. And then y-axis is, how do I spell this? Herfindahl Hirschman index. All right, let's just do 0.0A. And I need a better way of defining and differentiating these. So let's order them or make their circle size based off of how much of reserve 0, which is the minimum, not the minimum, which is the token address we put in. So how much USDC are they holding? I'm going to remove the chart legend and group by pair symbol. So now when I hover over, I can see, okay, USDC ETH has 3,000 LP holders and HI of 712, which is really good, and reserves of 441 million, roughly, versus USDC DAI here. It has a high number of holders, but its HI is still really close to 10K, which means that it must be still a very concentrated holding, where maybe 5 or 10 holders or less hold almost all of the liquidity. Right. We would expect to see almost like a perfectly linear movement here of sorts. So that's interesting on liquidity concentration. Let's look next at how volatile that liquidity is. So I'm going to now put magnitude on the x-axis, and then I'm going to put HI on the y-axis. and I'm going to take the logarithmic of both, circle by reserves again, right? And this is going to be magnitude, so volatility versus HI, right? So if something is highly concentrated and really volatile, that would be a bad sign, right? We probably wouldn't want to trust that one. So I'm going to remove this and then put pair symbol and see, all right, USDC ETH has like a very low HI and its magnitude is 1.6. That's pretty good. USDC DAI has a higher magnitude, about 100 times higher, and it has a much higher HI. And there's some tokens out here, like this USDC CAD that has a magnitude in the hundreds of millions, meaning it's super volatile, and its HHI is like basically almost all just controlled by one person. So I might actually want to change this from reserve 0 to number of holders instead, right? So I can see, okay, XCAD here that has a almost perfectly 10K HHI has 18 holders, right? The USDC DAI has 272 holders. There's some other ones here like DLP Duck also has 274 holders, but somehow such an uneven HHI. USDC USDT has a higher magnitude than we would like, in the hundreds, but its concentration is okay, and it has a high number of holders, right? So we might consider that still to be like a pretty good pair. All right, now that we understand the volatility and concentration of liquidity, let's try and understand the price impact, right? So now what I can do is say, all right, let me put price impact on the x-axis, and then I will put percent of reserves in the y-axis. So let's do this. So remember, this is percent of reserves token 0. And then this is price impact 0 to 1 simulated. And let's make both of these logarithmic. This should be a percent. 0.0% is fine. Actually, we don't need that to be logarithmic. And then for here, this is also going to be 0.0%. So we can see the highest is obviously here. What happens if I take this away? Nope, that's unreadable. The highest here is WETH, basically up here. Let me make this more clear. Let's do a circle radius with amount of reserves. No, that's too perfect. Let's do number of holders again. I'm going to turn off the legend, and then we're going to group by pair symbol again. So I can see, all right, WETH up here has about 43% of all reserves of USDC, and it has a slippage of 0.003 or 0.3%, right? And as you go down, the lower amount of reserve 0 you have as a percent, the higher slippage, right? So USDC mark here, if you swapped 2,000, not slippage, price impact. If you swapped 2,000 USDC into USDC mark, you would have a price impact of 25%, which is really big, right? We basically don't want to see anything above like 1% or so in price impact. So this is pretty interesting to see. We'll just call this price impact versus reserves, right? And let's make one last chart here. Let's look at volatility, right? So this is something we could have done yesterday, but I'm just going to take an X and Y logarithmic, and then let's make it logarithmic based off of number of, oh, not group by. Group by, we want symbol. But we make it group by number of holders. So we can see there's a lot of concentration in this area where the standard deviations are all around like 4%. Magnitude is all around 1, basically. Like this whole area is basically 1 to 1. And then you have a few outliers, right? There aren't that many outliers that are super like volatile. So let me actually change this group by away so I can edit things faster. So we'll make this. And let's also do this, right? And we'll call y-axis standard deviation of k%. x-axis is standard deviation of price percent, and we'll just call this chart volatility. And let's add the group by back. And lastly, let's just look at reserve percent as well. This story will be very obvious, I think, but if we take percent of all reserves 0 and then percent of all reserves 1, and let's do the logarithmics. It won't surprise you that most clusters have almost 100% in token 1. What did I just do? I close the tab. So it shouldn't surprise you that most of the tokens are 100% reserves. Sorry, it shouldn't surprise you that most of the tokens have 100% reserves in their other token, right? Because it's basically, oh, we're creating a pair with USDC that we want to easily swap into, and we're going to put basically all of our tokens into this pair, right? And rely on USDC ETH and USDC other pairs for routing between other swaps. So that just makes sense, but it's still good to see in the data. We're going to group by and then do number of holders. So ETH is the highest here and also the most balanced. They have a lot up here where it's basically, yeah, it's all almost like 100% in the USDC pair token. Oh, this one's 22%. Yeah, not bad. So let's put this on a dashboard just so it's easy to view. And we'll call this Uniswap V2 pair stability comparison. And I'm going to take, last week's dashboard and copy this text in here and compare liquidity stability across all pairs. It's applied to a certain period of months, and there's a threshold of minimum reserves in token inputted, and filter for inactivity, no swaps, or no liquidity in the last 10 or in the last X months. All right. And we're going to say pair stability comparison. Right. Now, ideally, we combine both these dashboards together and we can view everything at once. We'll leave that for after the course to do. But now I'm going to add in all my charts and just give it a second. And let's just format some things. So the summary table should be basically the whole thing. And we've got a lot of parameters here. I'm just going to order them like this. And we're going to make these all a little bit bigger, so we can see if we're trying to tell the story here. There's a concentration of liquidity. This is how it affects the magnitude of volatility. Obviously, price impact then comes based off of a lot of this volatility. And then your percent reserves shows you your distribution of token. Obviously, these ones up here, again, are all token pairs where the token 1, so the non-USDC token, is the highest percentage. And with that, we are officially done with all 12 days of queries. We have 2 dashboards now. You should really have a much better understanding of both usage of pairs as well as stability of pairs. Obviously, if you haven't been able to tell already, stability goes much deeper than usage does. And without stability as a context, you can't really understand usage. And yeah, from here, you could take things, compare across dexes. You could try and do this kind of calculation across the full protocols, so like all pairs, not just all like pairs of one token. There's really a lot of ways to keep going in depth with it, and we're going to have more details on that right after this.
Thank you, Andrew, as always. Now, we're ready to tackle the ultimate query, our competition question. What percent of pairs in Uniswap V2 is high quality? So to do this, you need to show how can you tell if a pair or a pool is high quality. So what we went through in the past 12 days in terms of usage and stability metrics should serve as a jumping point. And we're really excited to see how you approach this problem beyond what we've covered. All right, good luck.
Take care.
Bye.